Good morning, students. Welcome to the fourth part of the normal distribution. In this video, we will have some practical example of the last three videos what we have studied. If you remember, in the first video on the normal distribution, that is part 1, we have discussed about the basic introduction, basic theory. Second video have told us what are the basic properties of the normal distribution. Third video we have seen how to find out the area between the curves of f of x and the x-axis and use of normal table. And then last video only I have promised you to discuss the practical examples. So let us take this example. Here the question says that x is a normally distributed variable with the mean mu equals to 30 and a standard deviation sigma equals to 4. We need to find these three values or these three probabilities, right? So to understand this one, let me explain you the things given to us. We have been given mu, that is mean 30. Standard deviation is somewhere here if you represent, and it is given to us sigma equal to 4. Standard deviation is the spread of the curve on x-axis. This is the x-axis. If mu is equal to 30, that is mean is always of interest, it is 30. Somewhere here you will find 40, somewhere here you will find 45, and likewise up to plus infinity, and likewise minus infinity. The total of the x normal distribution curve will touch to the minus infinity plus infinity without ever meeting it, we considered. But we also have seen in the properties that sum of all this is equals to 1. But here we have many values of x, that is x equals to 40, x equals to 21, then x equals to 35, then x equals to 30. And to convert this, we need the integration of these many areas bounded with this. To understand that one, what we'll do now, we'll convert this using the standard formula, that is z equals to x minus mu upon sigma. And there are various values of x are available. So for x equals to 40, what will be the value of z? So this will be z equals to 40 minus 30 divided by 4. This comes 10 by 4, that is what? 2.5. Similarly, for x equals to 21, although it is x greater than 21, but I am talking about only x equals to 21 right now. We'll discuss what we'll do and how we'll solve for the greater than 21 and less than 21 with the help of graph in the coming slide. Similarly, for x equals to 21, z will be what? So z will be 21 minus 30 divided by 4, that is minus 2.25. Similarly, for x equals to 30, we'll get the value of z equals to 30 minus 30 divided by 4, that is what? 0. And similarly, for x equals to 35, right, we can solve z equals to 35 minus 30 divided by 4 will give us what? 5 by 4, that is what? 1.25, right? So these are the various values of z, that is z equals to 0, z equals to 1.25, z equals to 30, then z equals to 2.5. And now let's discuss how to use the normal table for all these values, right? So here we have the normal table, and we'll learn how to use the and how to find out the values of various values of z we have calculated. So z equals to ranging from 1.25, then we have another value of z is 2.25, and we have another value of z as 2.5. We'll see how to find out this many values. So what we are doing exactly with this table, you can see that the values of z is increasing from 0.0 to 3.9 here you can see, right? that means values of Z will be increasing like this. And here you can see in the columns various values are given, which is what the decimal places value, second decimal places value, right? So let me take an example to understand, and we have already seen this discussion in the last video also. So for this Z equals to 1.25, what we are doing now, we are calculating for 0 to Z to 1.25, right? This is what the fifth column we have, right? The fifth column is of interest, so let me highlight this column now, right? And we are interested for 1.25. This is what 1.2 line, right? So if you can move like this, 1.2 line is here, right? This value is of interest, 1.25. So Z equals to 1.25 is 0.3944. This is what 0.3944, right? Similarly, this is what 0 to Z to 1.25. Some of the time we are saying for Z equals to 0 also, right? And then let me erase this thing and write it more clearly for you. Right. So probability of Z 0 to 1.25 is like this. Similarly, for probability of Z 0 to next value is 2.25. How will calculate this? Similarly, we can go to this line. This is what 2.2. This is what 2.2 value of Z equal to 2.2, and 2.21, 2.23, and likewise we have 2.25. This value is 0.4878. 0.4878. Alright. And the last value, that is what Z equals to 2.5. So it is again probability of Z lies between 0 to 2.5. So 2.5 need not to go to any column. Here you can see that this value 2.5 is already given. So this is what the value of Z equal to 2.5, and this is what the corresponding area, right? So this is 0.4938. So what we did, basically we have divided our discussion into two parts. One is whatever the value of normal variate x is given, we have transferred or translated that value of x into the standardized variable Z. In terms of x equals to 40, we get Z equals to 2.5. For x equal to 21, we got minus 2.25, and similarly when x is 30, Z is 0. When x equals to 35, when we got Z equals to 1.25. This was the first discussion. And in the second discussion only, we have calculated the values of various areas or various probabilities or the various values of Z, which is likewise again, right? And now let me discuss with you that for the first question, how we'll find out for x less than 40, right? So here you have the solution, and before going on the solution, let me express you that we have already calculated the value for probability of x less than 40, and that is what probability of less than 40, that means Z is what? So if x is 40, Z is 2.5, and probability of Z equals to 2.5 is 4938. Let me copy that value here. So probability of Z 4938 is somewhere here, right? So what we have agreed, that is we got that probability of 0 to Z to 2.5 is 0.4938. Is this clear? Any doubt on this? If it is, you can go back and understand that 0.4938 we have calculated from the table itself, right? And now the question is, we are not interested for probability of Z 0 to 2.5. We are interested for x less than 40. So we have already converted. So let's trace this one. So x was 40, mu was this, and all. So we have converted this That means when x equals to 40, we have got the value of z as 2.5. So here the question is probability of x less than 40. That means here the interested area is what? Probability of z less than 2.5. And for this we need this kind of diagram. So let's try to understand. Somewhere here we will have 1, somewhere here we will have 2, somewhere here we will have 3, somewhere here we will have 2.5. So let's say this is what z equals to 2.5, right? Say this is what z equals to 2.5, and area which is of interest is this part, right? Do you able to understand? So we are interested to find out the area of all this, right? Where this is all now converted entire standardized z axis. So probability of z less than 2.5 means what? We are interested for minus infinity, probability of minus infinity to z to 2.5, right? And from the table only we have the value of this part only. That means 0 to 2.5. We have the value of this part, right? What about the value of this part? For that, can we write down this one as the sum of two parts, that is minus infinity to 0 and plus 0 to 2.5, right? And we all know that sum of all this area is equals to 1, and this part, that means is symmetrical to each other. That means left negative axis is symmetrical to the positive axis. So this part is 0.5. This part is also 0.5, but we have already taken the values from the table for this part. So this is what? This is 0.4938. Correct? And this part is what? This is 0.5. So if you can solve this one, that means probability of z less than 2.5 is equals to 0.9938, and that's the answer. Hope it is clear to you. Alright. Next question is related to x greater than 21, right? And for x greater than 21, again we need to understand that what was the value of z we have calculated and what are the values of z we have taken from the table. So for 1.25, you can see that this is what? 0.3944. So let me write down that value here. 0.39. Let me go back, and for, you can see that for x greater than 21, it is what? Minus 2.25, right? So we need the value of 2.25. So for that 2.25, this is the value 4878, right? 4878. Let us note down this value here. 4878. Okay. So copying the value here, that means probability of z lies between 0 to 2.25 is 0.4878, right? Okay. Now let's try to understand that greater than 21 part means what. So for that, let us take probability of x greater than 21 means probability of z greater than minus 2.25, right? Hope you understand how this value come. When x equals to 21, we have just translated z equals to minus 2.25, right? So where is minus 2.25? So let's try to identify here. Say it is minus 3, say it is minus 2, say it is minus 1, similarly 1, 2, 3 all are here, and it is in the z-axis now. So minus 2.25 will somewhere here, this is minus 2.5, and somewhere here it is minus 2.25. So let's say this value is z equals to minus 2.25. And area of interest is what? Z greater than minus 2.25. That means area to the right side of this one, right? Rightmost part in the x-axis or in the z-axis in the number line, hope you know, is what? the greater, and left hand side are the smaller. So here question is having interest in the right side part of the ordinate z equals to 2.25. So this is what the area we have. Alright, so can we write down this situation as area of minus 2.25 to 0, that means this part first, right? And the second part is probability of 0 to z to plus infinity, that means entire positive x-axis, right? And this part basically. So this is what we have known, that the sum of all the areas is equals to 1. So this part is 0.5, right? And we need to find out this part only. And you can see that we have already calculated from the table that probability of z lies between 0 to 2.25 is 0.4878. But here it is another question, minus 2.25 to z to 0. So now we need to discuss that since x-axis is having the symmetrical ordinates, so this part and this part will again similar and having the same value. That means this value and this value are same. So using the symmetry and concept of normal distribution, this is what 0.4878, and then the right hand side part is all along 0.5. So this is what probability of z greater than negative 2.25, or basically probability of x greater than 21 is 0.9878, right? This is what the answer for you. Hope it is clear to you. The next one more example for you is probability of x lies between 30 to 35. It's all very easy, and here we will understand that already we have converted the x-axis. That means for x equals to 30 we have seen z is 0, and for x equals to 35 we have seen z is 1.25. Alright, so for 1.25, how will find out the value, and it is also being calculated in the last discussion only. So here you can see that for 1.25 it is 0.3944. Let me copy it somewhere, 0.3944, right? Okay, so 0.3944. So we have calculated probability of z to 1.25 is 0.3944, right? Now we need to trace and shed the graph of the normal distribution to conclude the answer, right? Because without any setting you cannot say that this is the only answer. So let's try to understand. We are interested to find out the probability of x lies between 30 to 35, right, which we have converted in terms of z. So z is being converted as 0, and then it is 1.25, right? So this is what z equals to 0, and somewhere here let's say 1, so somewhere here you will get 1.25. So this area is of interest, right, which we have calculated from the table itself. So you need not to have any addition of 0.5 or subtraction from 0.5 as we did in the previous one, right? So this is what 0.3944, and it is the answer, right? So hope you understand this question, right? So we have discussed three different sections of a particular question, and I am very much sure that you have understand this one. For the basic concepts and the revision of properties of the normal distribution, please do visit the first 3 videos of the normal distribution. If you like the video, if you have any questions, please comment it. Thank you very much for watching the session.